Welcome to my channel. Let's start with topic transistor. I want to tell you that this topic has been deducted from the CBSE board onwards 2020. So in this chapter we would be studying about transistors, action of transistor. So in this case you should know about the formulas and how to apply them on the circuits. So these are important from the viewpoint of entrance exams, so must do that. So in this case we have transistors. So let's start with it. So transistor is basically a junction transistor formed by sandwiching a thin layer of either p-type or n-type, as you can see on the board. So in this case we are making a sandwich of three type of semiconductors. Like in the first case, the middle one is a p, and I have shown it in a way that it looks thin as compared to the n-type. So in this case, let's know what all these are and why I have marked them as E, B and C. So either we can make sandwich of n-type semiconductor, you can put n-type semiconductor in the middle, and if you are keeping n-type semiconductor, you must have p-type on both the sides, and if you are keeping p-type as a semiconductor in the middle, then you should have n-type semiconductor on both sides. Now in this case, as you can see, we have E, it is known as emitter. We have B, it is known as base. We have C, it is known as collector. Now in this case, what it means is that in the first case we have an NPN semiconductor or a transistor. So in this case, this, as you can see, in the first case the arrow is in upward direction. The emitter direction is in upward direction, whereas in this case it is downwards direction. So basically, if you want to remember this, you can memorize this as it will tell that the base current is flowing upwards, and in this case the base current will be flowing downwards. So this is one trick based on transistor to know where the current is. In the case of NPN, it is flowing upwards. Mark it as like this. In this case, as you can see, the arrow is downwards, that means the current is flowing downwards. So in this case we would be studying about the NPN transistor and PNP transistor in broad. So let's start with NPN transistor. So as you know, in the case of N, we have majority of negative charges or electrons, whereas in the case of P we have holes, and in N again we have more electrons as compared to holes. So now you can see that let us study this first. So in this case you can see we have N-type is the first, and it is connected to a negative one, and the P, the base, is connected to the positive one. That means it is in forward bias. The emitter base is the forward bias. That means this is considered as VEB. Now in this case, the second half, when we talk about second half, it is this direction. Then you can see that N is connected to the positive one, and P, the base, is connected to the negative one. That means this is reverse bias. Now as soon as you start the circuit here, the 5% of emitter electron, as you know that electrons will flow in this direction because you are providing it with current, and they are in majority, so they will try to diffuse from emitter to base. Now as you know that the base is very thin, that means holes present there are very less in number. Now these electrons will try to jump over here and try to diffuse into the positive one, but as the number are very less, so therefore only 5% of emitted electrons will find their place in the base or the p-type, and rest of the 95% will go into the collector region. They will try to reach the collector region because now we don't have the positive ones in the base. So they will try to reach the collector region. Now therefore we can say that the emitter current is greater than the collector current. Why? Because they will try to reach the collector current. So corresponding to each electron that is swept by the collector and that enters the positive pole of the collector base battery here, this is collector base battery, they will try to reach here, and then an electron enters the emitter from the negative pole of the emitter bias. The electrons will try to come over here and over here. Now thus in NPN transistor, the current is carried inside the transistor as well as external circuit by the electrons. So therefore you can point out that IE is equal to IB plus IC. So this is about the action of NPN transistor. So I will repeat this. In the first case, the first circuit is forward bias and the second one is the reverse bias. So in this case, as soon as you start the current, the electrons from the emitter will try to diffuse to base part and the collector part. So as you know that the base is very thin, so that means very less number of electrons will diffuse the positive electron in the B type. Now they will try to reach the collector, and as you know that the collector is in this case is N type, that means has many electrons in it. Now this will be now 95% of electrons will try to reach collector region and forming most of the current here. That means your emitter current will be equal to, as the emitter current is the highest, so it will be equal to base current and the collector current. So must do this, like in this case it is forward and in this case it is reverse bias. So that's how the NPN transistor works. Now if we talk about PNP transistor, now we have PNP transistor. In this case you can see again the first junction is forward bias and the second junction is reverse bias. Now in this case we have this will be a positive one and this will be a negative one. So in this case again it will be a forward bias, the second one will be a reverse bias again. Now why in this case? In this case the P type is the majority of holes. So in this case we have holes more as compared to the electrons. So in this case again the middle one is very thin. So they will the positive one will try to diffuse into the N type first, and as the number is very less, so they will try to jump to the P type, that is the collector one. So they will try to reach here again. Only 5% of holes will recombine with the N type here because it is very thin. And most of them will only be combining here, diffusing into P type and forming collector current, because they will try to reach here rather than N, because they will only diffuse with the negative ones. So they want more negatives, so they will try to reach the positive one, the P type. So in this case, thus it is forming the reverse bias, and the first one is forming forward bias. So in this case again IE will be greater than IC, and the same function works here as well. It will be IE equal to making IB plus IC. And remember that in PNP the emitter is like this, the arrow is in downwards direction, so the current of IB will be in the downward direction. And whereas in the NPN type is in the upward direction. That means your IB will be in the upward direction. So that's the end for the transistor part.